Hi, I hope you're doing well today. In today's lecture, we're going to go through what an indicator is and an example of how debugging is done using the print function and strings. Let's start with what an indicator is. The indicators that we see on charting platforms are plotted graphs of indicator values. What we're seeing now is the daily chart of QQQ. And in the bottom panel, I'm going to expand it. This is its MACD indicator. And let's pay attention to where my cursor is. Notice that there are three values and they keep changing as I move my cursor around. These three values make up the MACD indicator. I'm going to move my cursor to a point where the values are a little bit bigger. So right here, the red value is the MACD's histogram value and it makes up the bars that we see on the indicator. The blue one is the MACD value and it makes up the blue line that we see on the indicator. The orange one is its signal value and it makes up the orange line on the indicator. All three values are calculated using the close prices of daily candlesticks that we see in the chart above. Okay, we know that the MACD indicator's values are calculated using close prices. But how exactly are they calculated? Well, this is the formula, and it's pretty complicated. The good news is you don't need to know the formula of any indicator because most of them are pre-programmed. Or if not, you can just ask AI to give you the formula. Let's get back to the point. Essentially, indicators are plotted graphs of indicator values, and indicator values are the results of applying mathematical formulas to market data. Different indicators use different mathematical formulas, so each one gives you a different perspective on how the market is moving. In this table are some commonly seen indicators and what each of them tell you. Moving average is by far the most widely known indicator, and it gives you the general direction that price is going. Relative Strength Index, or RSI, also pretty widely known, gives you the speed and magnitude of recent price changes. The Volume Weighted Average Price, or VWAP, gives you the true average price of an asset throughout a trading day. Alright, that's it for indicators. Let's move on to the example. Please open up Quant Connect, create a new algorithm, and paste in example 1 from today's lecture resources. Here I have example 1 pasted in, and there is a bug somewhere in this code. I'm going to run a backtest, and you'll notice that its performance is pretty terrible. Alright, the backtest is done. From the 1st of January 2021 till today, the 10th of March 2026, it only made a 10.55% return, which is not good. Before we continue, let me explain how the trading bot is supposed to trade. Remember, there is a bug somewhere in the code, so currently it is not trading like this. The first thing that it checks is it invested in NVIDIA? If not, it checks if NVIDIA's daily MACD crossed above its signal. If so, it uses all of the cash that it has available to buy NVIDIA. If not, it does nothing. On the other hand, if it is invested in NVIDIA, it checks for a 10% take profit. If it finds that it should take profit, it sells NVIDIA. If not, it does nothing. To figure out where the bug is, we need to do some detective work. There are two steps in our approach to debug example 1. Step 1 is to check if the entries are correct. If the entries are correct, then the problem must be in the exits. Both steps will need to be conducted from the Orders tab of the backtest page. Let's navigate to it. We're going to scroll down, and in this panel, click on Orders. Let's pay attention to the Type column. To check if entries are correct, we look at Buy Market on Open Orders. We have a lot of them, so we're not going to check every one. We're just going to check the first 3. The first one was submitted on March 17th, 2021. Here I have NVIDIA's daily chart opened up. At the top are its daily candlesticks, and at the bottom is its MACD indicator. Because the trading bot's entries depend on the MACD indicator, we are going to expand it. Looking at the indicator, the yellow line is the MACD and the blue line is the signal. An entry is supposed to happen when the MACD crosses above the signal. In other words, when the yellow line crosses above the blue line. It happened many times in this chart. The first one is over here. The second one is over here. The third one is over here. The fourth one is over here. The fifth one over here, the 6th, the 7th, the 8th, the 9th, and the 10th. The first entry was on March 17th, 2021, which is over here. This entry was correct because the MACD did cross above the signal on this date. Now let's look at the second entry, March 26th, 2021. That happened over here. On this chart, it doesn't show a crossover, but it does show that the MACD almost touched the signal the day before, on March 25th, 2021. Different platforms have different data sources. It may be that QuantConnect's data source showed a crossover on the 26th, but this charting platform's data source does not. Okay, so the second entry is a little iffy. Let's look at the third entry, 21st May 2021. On the chart, 21st May 2021 is right here. The yellow line did cross above the blue line here, so this entry was correct. Since the second entry was a little iffy, let's check one more entry order to get more assurance. The fourth entry was on August 5th, 2021. August 5th, 2021 is right here. This entry is correct. We've checked 4 entry orders. One of them was a little iffy, but the rest were on point. So we can be pretty confident that the trading bot is entering positions correctly. So the problem must be in the exits. Because the trading bot exits on 10% take profits, those are price movement based. It is very difficult for us to use a chart to determine whether they are correct. This is where printing and combining strings come in. I'm going to go back to the main.py file where the code is in, and I'm going to scroll down to find where the exit logic is. Here it is. If current price is 10% above average price. If this condition is true, the trading bot is going to submit an order to sell all holdings of NVIDIA. To check if this exit is running correctly, we are going to print the current price and average price that triggered it. This next part is not in the example that I gave you, so you might want to follow along as I code. Before the exit order, I'm going to create a variable that stores the current price. We're going to learn how to do this on QuantConnect in later lectures. I'm also going to create a variable that stores the average price at entry. Next, I'm going to create a main string that combines both of them with a basic message. Let's dissect this main string. It starts with a string, NVIDIA current price, and then a plus operator, and the string function with current price as input. We haven't gone through the string function, but essentially it converts the inputted object into a string. The reason why we convert current price into a string is because current price is a float, while main string is supposed to be a string. We cannot combine a string with a float. In order for current price to be a part of main string, we need to convert it into a string. Following the string function is another plus operator, and another string, average price at entry, and another plus operator. In the last part, the string function is run again with average price at entry as input. Next, we are going to print main string. Important note, Python's print function does not work on QuantConnect's backtesting and live trading system. To display information when backtesting and live trading, we need to run QuantConnect's substitute, self.log. Following main string, we are going to print and run self.log with main string as input. Let's run a backtest. All right, the backtest is done. To see the information that it printed, we're going to scroll down. In this panel over here, we're going to click on logs. In this backtest, we have 3 pages of logs. And currently, we're on page 3 of 3. Let's go to the first page. Remember that these messages are generated only after the trading bot confirms that this condition is true. If current price is 10% above average price. Let's take a look at the messages. Let's look at the first one. NVIDIA current price, $12.69. Average price at entry, 13.08. Okay, there is a problem here because 12.69 is not 10% above 13.08. In fact, it is less than 13.08. Let's look at the next message. Current price, 12.91. Average price at entry, 12.78. This is problematic as well because although 12.91 is greater than 12.78, it is not 10% above 12.78. Let's look at the next one, 15.57 and 15.16. Yeah, 15.57 is not 10% above 15.16. Okay, we've found our bug. It's in the exit logic. Let's go back to the code and see how we can fix it. I'm going to check this condition. If current price is less than average price times 1.1. Okay, the problem is right here. This is the symbol for less than. What we need is the symbol for greater than. So I'm gonna change it to greater than. And now this condition makes sense. If current price is greater than average price times 1.1. Let's run another backtest to see how this one performs. All right, the backtest is done. And as you can see, the return from this backtest is much higher than the previous one. This is 265%. The previous one was only 10%. To see if we truly fixed the bug, I'm going to go back to the most recent backtest we ran, scroll down to the logs tab, and check if these messages make sense. Let's look at the first message. NVIDIA current price, 15.17. Average price at entry, 13.08. This makes sense because 15.17 is more than 10% above 13.08. Let's look at the next one, 16.73 versus 15.16. This one also makes sense because this number is about 10% above this number. The next one is 22.58 versus 20.42. This one also makes sense because this is about 10% above this. All right, after checking these messages, we can confirm that we've successfully fixed the bug. Before we end today's lecture, let's look at what we learned today. We learned that indicators are plotted graphs of indicator values, and indicator values are the result of applying mathematical formulas to market data. Different indicators use different formulas, so they tell you different things. We also learned that Python's string function converts the inputted object into a string. The print function doesn't work when backtesting and live trading on QuantConnect. To display messages, we need to run its substitute, self.log. To see messages generated by self.log, we check the logs tab of a backtest page. For tomorrow, we have a couple of coding exercises, no lectures. And that's it for today. I hope you have a great day ahead, and I'll see you the day after tomorrow.